Second graders, it is day 2, it's week 5, and we're learning different properties of multiplication and division. So we learned distributive property, and today we're going to continue that on. So as a review, use the distributive property to solve this problem. Go ahead and work on that right now, and I'll give you a few minutes and then we'll see how you're doing. Remember, use place value to help you break up that 36. So hopefully you're already thinking 30 plus 6. And then I take the times 4 over here. That's my first step, setting it up. Now I'm going to take 2 set of parentheses with my plus sign. Go ahead and write what you're going to do next. I'm going to take this times 4 and put it on each of these parentheses on the right hand side. And then I'm going to take my 30 and bring it over here, and my 6 and put it over here. Okay, I have set this up the right way, but it's not finished. I have to still solve for my answer. I don't know what 36 times 4 is, so I've done a lot of work so far, but I've got to actually come up with my answer. So this side equals 120 plus 24. And if I add those up together, because that's what this tells me to do, I'm going to get 4, 4, and a 1. My answer for this problem, 36 times 4, is 144. Hopefully that's what you got as well. We're going to move on to what our lesson is for day 2. Day 2, we're going to apply the associative property and the commutative property to multiplication. So what are the properties of multiplication and division? Hopefully so far you can say distributive. Looking at this, we can say, well, there's associative and there's a commutative properties. What are the properties of multiplication and division? How do you determine which property to use? And then what are the models that can help you represent those properties of multiplication and division? And how do these properties apply to both multiplication and division? So let's get started. We have vocabulary. We have the word commutative property. It states that change in the order of 2 factors, it doesn't change the product. And remember, product is the answer. So if I change the order, it's not going to make any difference at all. I'm going to get the same answer. So here's an example. 5 times 4 is equal to 4 times 5. See how we did that? Was 5 first. We just switched these two together. We just switched them. Both have the product of 20. 5 times 4 is 20. 4 times 5 is 20. We have the same thing with addition. If this was addition, 5 plus 4 equals 9. 4 plus 5 equals 9. It didn't change. So the associative property states that change in the order of 3 or more factors does not change the product as well. It doesn't matter. Now we've got 3 factors, and if we change that order, it's still not going to change the product, which is the answer. So here's an example of that. I have 4, 5, 2, 4, 5, 2. I have the same factors, but this time my parentheses say to multiply these 2 first to get my answer, or to start my answer. This one says to multiply the 5 and the 2 first. Parentheses are telling me that I need to multiply that first. And in this case, it's still not going to change my answer. Both of these are going to equal 40, because 4 times 5 is 20. Then this means I have 2 20s. 2 times 20 is 40. Here I've got 10. 5 times 2 is 10. And then if I multiply 10 times 4, I still get a 40. It's the same answer. So we're going to start with the commutative property first. The commutative property is like a community. Still the same no matter what order they're in. This means that I can change the order of the factors without changing the product. And something just to kind of remember is that you switch. You're just switching the order. That's all you're doing, you switch. So 6 times 8, I have 1, 2, 3, 4, 5, 6, 7, 8. Here's where my 8 goes. and I have 1, 2, 3, 4, 5, 6 rows of 8. Oh, now we're going to switch the factors. 8 times 6 looks like this. It's taller because now I have 1, 2, 3, 4, 5, 6, 7, 8 rows, and there's 1, 2, 3, 4, 5, 6 in each of those rows. But I have the same amount in there. If I count them all up, there's still the same number in there. 48 in that one. Let's see. We say we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. 48 in both of those. My product is still the same. So let's practice. Using your knowledge of the commutative property and groups of, we'll model the following equation, 8 times 4. So, how many groups am I going to have? You guessed it, I'm going to have 8. 4, 5, 6, 7, and 8. Each one has 4 in there. So if I count all of these up, 8 times 4 equals 32. 4 times 8. Now all I've done is I've switched my factors. Now I'm going to have, how many groups will I have? Yeah, my first number, 4 groups of them. And there's 8 in each of those, so I end up with the same product of 32. It did not make any difference. This is commutative property. Okay, so which equations show the commutative property? Is it 6 times 4, 12 times 2, 5 times 2, and 10 times 1, 4 times 7, and then 7 times 4, 12 times 2, and then 6 times 4. Which one of those in there did we do that switch with? Well, I thought it was going to tell us. Last time it did. So it's this one right here. These are the same factors as over here on this side. All we did was switch. So let's practice. We have 7 times 8. So 7 times 8. And we're going to do our equal groups. We could do rows. 1, 2, 3, 4, 5, 6, 7. I'm going to have 8 in each one. So there's 1, 2, 3, 4, 5, 6, 7, 8. And I'm just kind of going through here. Look at what I have on top. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I feel like I'm doing a dance or something when you count by eighths. Okay, there's my crazy array. So I have 7 times 8. 1, 2, 3, 4, 5, 6, 7, 8. If I counted all of these up, I'm going to end up with 56. Now, if I'm going to show commutative property, then I would switch my 2 factors and I would have 8 times 7. And now that means that I'm going to have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. There'd be 7 in each row. 1, 2, 3, 4, 5, 6, 7. And I keep going. This time counting by 7. Two, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Counting all of these up, I would still get the same product of 56. Commutative property just means we switched the order of the factors and we have 2 of them. Okay. The next one, 9 times 6. Whoops, touched that on accident. 9 times 6. If I were to switch these two, it would be 6 times 9. Same thing, 9 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. This takes a little while. So remember, what I'm making right now is an array for this problem. And if I count these all up, I'm going to end up with 54. Now I'm going to do the same thing with 6 times 9. I'm going to have 6 rows. 3, 4, 5, 6. 3, 4, 5, 6, 7, 8, 9. Boy, this takes a little while. I am going to still have the same number of x's in here if I keep going with that one. Okay, 9 times 6 equals 54. 6 times 9 equals 54. This is commutative property, and it means to switch the factors. The associative property states that a product does not change when 3 or more factors are multiplied. Basically, you can multiply the same 3 factors in any order and the answer will be the same. It does not matter which 2 are multiplied or associated first. So here I have 6 times 3 times 4. We're multiplying these 3 factors. So I can do 6 times 3 first and then times 4. Or I could do 3 times 4 first and then multiply the 6. Or I could do 6 times 4 first and then multiply the 3. Using the same 3 numbers in each equation, I get the same answer every single time. So the 3 factors are the same. They're always going to be the same though in each one. I have 6, 3, 4, 6, 3, 4, 6, 3, 4, 6, 3, 4. I did not change my factors, so that's something I want to make sure you guys understand. The factors didn't get changed. I just changed by putting parentheses or moving them, in this case, which one I'm going to do first. So we have 6 times 3 times 4. We're multiplying the 6 times the 3 first, then we're going to multiply the 4. Over here is saying, no, we're gonna put parentheses around the last 2. So either the first 2 or the last 2. And in this case, we had to move the 4 over so it could be here. And I could put this, because I'm not going to go like this. Let's see, if I need to get my 4, I can either do these first 2 or I could do these first 2, but how would I multiply the 6 times the 4? I had to actually move it over, and that's all they did, is they moved it over. So you can see that you can do that as well. So when we do that, 6 times 3 is 18. Then I do the times 4. So now I'm going to break that up, 18, because I don't know 18 times 4. I'm going to break it up into 10 plus 8. We're doing the distributive property now. And then I'm going to multiply that 4. And when we break it up, here's my times 4, my times 4. Bring the 10 here, the 8 over here. And I get 40 for this side. Over here I get 32. I'm going to add those 2 together. And we get 72. Let's see what happens on this side. Over here I get 3 times 4. Parentheses tell me I have to multiply the 3 and the 4 first. I get 12. Oh, that's different than what I got before. Let's see if it comes out at the end the same. Bring down my 6 times 4, or times 6. I have to break that down. We're going to make it 10 plus 2, the 12. Here's my 6. Remember, 2 sets of parentheses with the plus sign in the middle. And this case, our 6 times 6 is going to be on this side because it's on this side, just to make it easier. Here's the 10, here's the 2. 6 times 10 is 60. 6 times 2 is 12. I bring the plus side down, I add those. Oh, I got the same product. Next one. 6 times 4, 24. Bring times 3 down. Distribute property. We're going to distribute that 24. We're going to make it 20 plus 4 times 3. And now we're going to actually do the distributive property. So here's the times 3 on each one. Put the 20 on this side, the 4 in here. These have the multiplication already in it because this whole piece comes over. Plus, put them together and we end up with 60 plus 12. And it does. Look at all 3 of these have the exact same answer because we're using the same 3 factors. And it doesn't matter which order we're going to do those in. This is the associative property. So which of the following equations show the associative property? Would it be A, B, or C? Remember, it doesn't matter the order of our factors. Well, I'm noticing over here that I've got a 5, a 2, a 5, and over here I've got 5, 10, 1. No, because I remember earlier we were reading that it's supposed to be the same factors. Here I've got 3, 6, and 2, 3, or 6, 3, and 2. Hey, that could be it, but I'm going to check it a little closer just to make sure. And these don't have the same factors as on this side, so this must be it. But let's check and make sure. I can multiply the last 2 numbers, or oh yeah, multiplying here 2 times, or 6 times 2, and here it's the 3 times 2. I didn't do the 6 this time, and over here first, and over here I didn't do the 3 first. So this is my answer, is B. Let's do some practice. 5 times 3 times 7. And then we're going to switch it, and we're going to have the last 2 numbers. So here's, I'm multiplying the first 2 numbers, and here it's the last 2 numbers. Okay, so we'll go ahead and work on this one. So here I've got 5 times 3, which equals 15, times my 7. Oh, I don't know, 15 times 7. I'm going to have to break that down into 10 plus 5, and then the times 7. So then I'll do my distributive property. I'm going to have 2 parentheses, 2 big sets, and a plus sign in the middle, times 7 inside on both sides. Bring my 10 over here and my 5 over here. Okay, do I have my answer? No, I have to now multiply out. 10 times 7 equals 70. 5 times 7 equals 35. And when I add those 2 up together, I get 105. Okay, let's try this side. 3 times 7 equals 21. Bring in my times 5 down. I didn't show that before, that's what I did. Okay, and then that's a huge number, so I'm going to make this 5 times, and I'm going to break my 21. So there's different ways I could do this. I'm going to just make it the way we've been working on. I'm going to make it 20 plus 1. But I could have made it some other way to make 21. Okay, let's continue. I have 2 sets of parentheses. My times 5 is on this side, so I'm just going to keep it on the left side. My 20 is over here, and my 1 is on this side. All right, 5 times 20. And then 5 times 1, I add those 2 together and I get 105. So I have the same answer, just like we talked about before. This is the associative property. There's a lot of work going on in here. This looks like high school math or something, and we can do this. We just have to break it down. All right. Oh, they had another one here. I'm going to skip that one because I've already erased all my work. It's going to come out to 105. Match the definition to the property of multiplication. So we have these three properties right now. So this one says that it states that change in the order of the two factors does not change the product. Now it does say two factors, so when I see that word two, I know it's not going to be the associative property we just did, because that was three factors. So that means it could be distributive or it could be commutative. States that change in the order. Oh, I also remember that we talked about this word. So which one do we just switch them? Because that's what we're doing, we're just switching them. Hopefully you're thinking about the commutative property. B says that it states change in the order of the three or more factors. Three or more factors does not change the product. Man, I remember we just did that one. Okay, and the last one, strategy to break up one factor of the multiplication problem to solve it quickly because it's so big already. So that would be our distributive property.